Question 1. What fundamental quantum process describes how a forward-biased LED converts electric current directly into light? In a forward-biased p-n junction, injected electrons and holes spontaneously recombine across the bandgap, releasing their excess energy directly as photons. Question 2. Why are direct bandgap semiconductors like gallium arsenide preferred over indirect materials like silicon for making LEDs? In direct bandgap materials, the conduction band minimum aligns with the valence band maximum. This allows carriers to recombine directly without needing a crystal lattice phonon to conserve momentum. Question 3. What is the primary method used to produce bright white light in modern residential LED bulbs? Most white LEDs utilize a blue-emitting gallium nitride chip coated with a yellow phosphor. The combination of transmitted blue light and phosphor-emitted yellow light produces white light. Question 4. Who is widely credited with inventing the first practical, visible spectrum red light-emitting diode in 1962? Nick Holonyak Jr. invented the first visible spectrum semiconductor light-emitting diode in 1962 while working as a researcher for the General Electric Company. Question 5. Which material breakthrough enabled the creation of high-brightness blue LEDs, completing the RGB triad? The fabrication of high-quality gallium nitride crystals, pioneered in the late 20th century, made high-efficiency blue LEDs possible, completing the red-green-blue spectrum. Question 6. What design feature is integrated into LED surfaces to bypass total internal reflection and improve light extraction? Textured surfaces and photonic crystal lattices disrupt total internal reflection at the semiconductor air boundary, allowing more generated photons to escape. Question 7. What parameter measures the ratio of emitted photons that escape the package to the total number of injected carriers? External quantum efficiency measures how many generated photons successfully escape the device relative to the number of electrons injected. Question 8. In an LED's electrical characteristic curve, what is the turn-on or forward threshold voltage primarily determined by? An LED's forward operating voltage is directly linked to the bandgap energy required to excite charge carriers, meaning blue LEDs require higher voltages than red ones. Question 9. What non-radiative loss mechanism is the primary cause of efficiency droop in GaN-based LEDs operated at high current densities? At high injection currents, Auger recombination increases. This is a non-radiative process where the recombination energy is transferred to a third carrier as heat. Question 10. What class of LEDs uses carbon-based semiconductor molecules instead of inorganic crystals, enabling flexible displays? Organic light-emitting diodes utilize carbon-based molecular films. Their thin, flexible profile makes them ideal for high-resolution bendable displays.